Okay, so that brings us to exercise 11.4, where we'll be looking at array operations and modifications. So we first need to create 3 arrays, and I think I'll just insert some spaces here. So we have v1, and we have one here, v2, and then we get v3 like this. Okay. So integers, some more integers, and ones. Okay, cool. So now we need to check what happens if we want to do element-wise addition. So element-wise addition we can do like this. And I actually think I accidentally mentioned this in an earlier video. But this is what we could, how we can add them together. So this is v1 plus v2, and we can also do it like, or we cannot do it this because they have the wrong dimension. So here you can see this error that pops up, and it basically says this one, v1 has 5 elements, and this one only has 4, so that's a problem because I don't know what to do with the last element that doesn't have a corresponding one in v3. But at least we can do this, and that returns a new array where the first entry is this plus this, and the second is this plus this, and the third is this plus this, and so on up until this plus this, which is the 12 here. Element-wise multiplication. Yeah. So what happens if we do this? We multiply them together element-wise. So we get a new array. This times this, 3. This times this, 8. And this times this, that's 15. And this times this is 35. So that's how we could multiply them element-wise. It's important to remember that we can also just multiply with an integer, and that will multiply each entry in v1 with 2. So it also works if one of the entries is not an array, then it's just applied to every element of v1, which is called broadcasting. Okay, apply the sign function to each element of v1. In that case, 1 simply has to know or guess that there is an np.sign function. And if I call it with v1, it will be applied to each element. So in this case, the first element will be, let's see what v1 was. It was 1, 2, 3, and 4. So the first element will be the sign of 1, and the second element will be the sign of 2, and so on and so forth. But this is how we can apply a function to each element. It's important to remember that I'm using the numpy sign function. And this is where we get into problems because there is a math.sign function, and that is actually a different function. It computes the same thing, but this one works with numpy arrays, and I am really, really sure that this one will not work with numpy arrays. It will be a little bit embarrassing if it does. Fortunately, then, I mean, it could theoretically work with numpy arrays because maybe Python had somehow accounted for it, but it doesn't. So from now on, when you want to do things with numpy, it's important to remember to do numpy dot the function you're interested in, not math dot. Okay, so that was that. Sum all elements of v1. Well, we can do sum again, and that'll give us the sum. And we can also do shape, and that'll give us the shape. Remember this, it's just important to keep in mind this return a tuple, because internally in Python this is an array of dimension, like this shape is basically always a tuple. So if it's only one dimensional, it's still a tuple, but just a tuple with one element. If you want the number of elements in an array, you can use the size variable, and that will actually give you the number of elements. This also works for matrices. So if I do c.size, I get 12, because there are 12 elements in total. Yes, again, c.shape, we saying that a couple of times, that's 3, 4. Okay, consider the array V. Let's do that. I'm considering V now. It looks like this. Okay, array considered. Modify V in the following way. Oh no. Set all negative values to 0. Okay. So in order to do that, we would use logical indexing. So we would get all the negative elements like this, or rather we would get the indexes of the negative elements, and then I could do v of these indexes should be set to, what was it, 0? Yeah, 0. So now we set them to 0, and that modifies v a bit. Okay, set all values that are less than the average to 0. Okay, is that the average before or after I set them equal to 0? That's a good question, right? I guess it's after, because that's easier for me. So we can compute the mean using the mean function. So the mean is actually it's the sum divided by the number of elements. So we can compute it manually like this. But this is a little bit simpler. It's a little less error prone, because here we could, I don't know, it's a little hard to make a typo here, but we could imagine that we could make a typo somehow. So this will get us the mean, and then we want to set the elements that are less than the average to 0. So we need to get the elements that are less than the mean. These are these ones, and now we set them equal to 0. So remember that v was like this, and the average was 3, so that would be element. It would be all the zeros basically, and then it would also be this one that would be set equal to 0. Let's confirm that, and that is indeed the case. Multiply all positive values by 2. I guess we need to reset v, because otherwise it becomes a little bit trivial. So let me reset v. I'm just pressing up on the keyboard to go back. So here we got v. All the positive elements multiply all positive values by 2. I'm thinking if I need to modify v and set the entries equal to the positive entries equal to 2 times the earlier value, or I need to create a new array of just the positive entries. I guess it's the later. So in order to get, first I need to get all the positive entries. So those are the ones that are positive, probably means greater than or equal to 0 in this case. So get the positive entries like this, and then multiply them by 2. So that would be one way of doing it. In case I wanted to update v, so I said I should update v by setting all the positive entries, that is this entry, and this, and this equal to these elements. In order to do that, I could do it like this. I could say v of v greater than or equal to 0 is equal to this times 2. That would actually also work. So let's just confirm it works. Remember that v used to be this, and now it is 8 and 14, and this is not changed, and this is changed, and so on. So what I'm using here is that when I select the entries here, I can assign them to any array as long as it has the right number of elements. In this case, I assign it to this array from up here that I regenerate in a single line, and that's basically how this works. I could also maybe it's a little more clear why it works if I just set all the positive elements equal to 100, and that will do this basically. Okay, so again, this is an instance where we can do something in a single line that would maybe require a loop and an if statement if we wanted to do it in normal Python with what we know so far. Okay, so multiply all positive values by 2. I think we've done that. Raise all values to the power of 2, but keep the original sign. Okay. So keep the original sign. So let's see. If there is a okay. Let's reset v. Let's start with that, because right now v is too big. So where did v go? There's v. Fine. I think there's a sign function. No, there isn't. np.sign. So yeah, that works. Okay, so that this function gets the sign of the elements of V. So 1, 1 because they have positive sign, and minus 1 because it has negative sign, and 1, 1, and so on and so forth. Okay, so now we want to raise all values to the power of 2 but keep the original sign. So this first thing I did here was to figure out how I could get the sign. So let's just bracket that off and then focus on the first part of it. Raise all values to the power of 2. So raising something to the power of 2, like let's say I want to raise 4 to the power of 2, it basically means like raising it to the 2, like power of 2 like this. Of course, this syntax doesn't work in Python. We would use the double multiplication sign and then compute 4 to the power of 2, 4 times 4, that's 16. This, of course, also works for arrays, like this. So this is V, where each element has been raised to the power of 2. So 4 to 16, 7 to 49, minus 2 to 4, and so on and so forth. Keep the original sign. What I think think is meant by this is that these should be exactly like this, but this entry with 4 should have a minus in front of it, because that's the original sign. And then this should be kept like 9 should go to 81, 3 to 9, and minus 6 should go to minus 36. So we can see that from what I've done here, we are just missing some minuses in the right places. Now, what I could do here is that I could use my earlier experiment, and let's set a parenthesis, and then I can multiply that with the corresponding signs in order to get the signs added in the right place. So I'll multiply the first entry with 1, and the second entry with 1, and so on, and then the third entry with minus 1, and that will fix the signs. So I do that using np.sign of V, and that works. It's a little bit tricky because you need to sort of figure out how to get the signs in order to work this exercise out, and that of course requires that you know that there is an easy way in NumPy to get the signs of something. I knew there was, but as you could see up here, I didn't actually know what the function was called, so I was experimenting a little until I was able to guess the right approach. So this is the way you could potentially solve this exercise in single line with NumPy. Okay. So I think I'll stop here and continue in the next video.